Let's talk UV maps. A lot of beginners are intimidated by UV maps, but they're really not that complicated, so let's talk about it. Let's have a basic tutorial about UV maps. I'm showing you here in Blender, but the truth is, this is universally true. UV maps work the same way in every piece of software on the planet. The buttons for interfacing with them might be different, but they work the same way everywhere. So let's go ahead and learn about it. This is a mesh. It's a box. It's gray. We don't want it to be gray. We would like to have some texture on it. So we pass the program a texture. And we say, put this on our box. And it might look like this. But in order for that texture to get put on our box, the program has to understand what part of the texture goes on what part of the box. And that's a UV map. So it looks something like this. Here is our UV map. Each face of the cube has a little thing on the texture showing us where it is. And if we were to move it around, you can see how it changes in the right-hand window. And if we were to rotate it, you can see how it rotates. That's a UV map. That's all it is. Every single face has to be on this texture so that it knows how to map the texture to the faces. It's just that straightforward. Now, just so you know, this isn't specified in pixels. It's specified in %. So this is 0 and this is 1. That's so that you can use any size texture that you want. You don't have to worry about how many pixels your texture is. But most meshes are not quite as simple as this cube. For example, we have this lady here. Oh, it's the Blender standard lady. She has a lot more faces than the cube, and if we take a look, every single one of these has to be part of the UV map. So there it all is. Look at that. It's a lot more complicated than the box. You can't just splash her flat onto the 2D image. You've got to kind of cut her apart and stretch her out. So that's exactly what we're doing. For example, here is one of her legs. You can see it moving on the right-hand side. See that? And here is her torso. See that? And here is her face. See that? So this UV map was made by choosing what parts of her should be their own islands. Each one of these things is called an island. So her face is one island. In order to do that, in this case, we've drawn these little red lines here in Blender, and they tell the software where each island should go and where the seams of the island are. Then when we tell it to unwrap her, it just takes those islands and tries to fit them onto this space, and that's exactly what it's done. But what makes for a good UV map and what makes for a bad UV map? What's with that checkered grid that they seem to use? Well, basically, some parts of your model need more detail and some parts of your model need less. For example, her legs probably don't need to eat up a quarter of the texture because they don't need that much, detail. We're not going to be giving her a complicated tattoo on her leg, for example. So we can shrink those way down and just shove them over into a corner somewhere, right? On the other hand, her face is kind of important. We might give her scars or acne or even just lipstick, and it's important for us to have enough space on the texture to actually do that. So we might rotate her face and then scale it up so that it fills a lot of the texture. That way, the more of the texture it fills, the more we can actually just spend on her face, the more pixels we can spend on her face. So right now, like a quarter of the image is her face, so we can put a lot of details in. Whereas if it was just this little teeny piece over here, we wouldn't be able to fit any details in. Similarly, we've got stuff like the back of her head. We don't need very much detail on the back of her head. Nobody's going to look at the back of her head and expect, delicate detailing. So we might shrink that down and stuff it into a corner somewhere. So what makes for a good texture and what makes for a good UV map and what makes for a bad UV map is entirely about whether or not you have enough detail for the parts that you want to have detail on. And that's why that grid exists. The more grid tiles you can see, the more detail you're going to have in that part of the mesh. It also helps to let you know whether you've got it on like this or like this. or upside down, or who knows, So that stuff is just there to help you try and figure out how big your pieces should be and how they should be oriented. The only other big concern is your islands cannot overlap. In a few very, very specific situations that might be allowable, but nearly all of the time, your islands should never overlap. And if you use the automated unwrapper, they won't. But when you start to fudge around with it and scale things up, move stuff around, you might end up overlapping, and then you have to move, things out of the way. So, what makes for a good UV map? Details where you need them, and no details where you don't. It's pretty much that easy. The thing is, we can tell our software to do a lot more than just put colors onto our models. We can do this. This is fine. And then we can, grab textures that we want from the internet and just stitch them together into the right spaces and then move our character UV mesh around until it's all worked out. Same with buildings or whatever else you're doing. But we can do a lot more than just put colors onto our objects, because textures are the main way that we tell the rendering software what to do with the surface of our mesh. We can do so much more than just put colors on. For example, over here, we've got a character with scars across her face. Now, the way that I did that is I drew those scars with, a brush in sculpt mode. But our character does not have that many polygons. Our character doesn't have enough polygons to support those cuts in terms of, mesh on the surface. There need to be like slices all around here, and it would be, a lot of extra density, a lot of extra faces. So what I did is I simply modeled it in a high resolution mode, and then I baked that high resolution mode down onto the low resolution model, and I use a normal map that looks like this in order to figure out, what parts of the mesh should have dents in them. And if we were to just hide this, you can see how there's her scars. Now, this doesn't look like anything useful to the human eye, because it's not built for the human eye, it's built for the computer. So I told the computer to do some math on a very high poly model to turn it into a low poly model, and it baked the result into this normal map, and that way every piece of software on the planet can tell where this model should have dents and where this model should have like things going up and things going down and things getting damaged. But we can do more than that. We can tell it where the mesh should be transparent. We can tell it where the mesh should be metal as opposed to flesh or fur or whatever else. We can even tell it things like, this is where the mesh should be shadowed, so you don't have to calculate global illumination. This is where the mesh should have subsurface scattering. This is where the mesh should have extra tessellation when the player gets close. We can do an enormous number of things with it because this is just a way to communicate with the shading system. We say, here are the instructions for every point on our mesh, and the shader just does whatever we tell it to. So whenever you hear terms like baking, what that means is that we're taking some really expensive, high-definition version of whatever we're making, and we're turning it into a really simple version by making a texture that perfectly tells it how to recreate that complexity. And that's all there is to UV maps. The reason why we don't want any of these islands to overlap is because all of that computational stuff, where we take that high-res model and bake it down into something simple, if there's overlapping islands, then it won't know which parts of the details to bake down onto the texture. And a lot of engines do this sort of baking automatically. For example, Unreal and Unity will both automatically create light maps so that they can keep track of what part of the model is in light and in shadow without having to recalculate it every millisecond. There's also things like you can have multiple UV maps, so you can have UV1 and UV2, or you can have submeshes that have different UV maps attached to different textures. You can go a long way with this sort of stuff, but at its core, it's not as complicated as people make it sound. You're just taking your 3D model and you're telling the computer how textures get applied to it. And then you can use those textures to do literally anything. And that's it. See you around.